All right, thank you. So this is the panel on global perspectives and makerspaces in education. And so the backstory is that all of the three people who are going to be on our panel, about which more in a second, kind of submitted something that essentially said, well, we're running a makerspace in an interesting part of the world, and here's our story. And so we said, well, wouldn't it be fun to, instead of having a bunch of short talks that are very similar, to sort of put them all together and then let you essentially compare notes on that. So that was the idea there. So we have three panelists, and I hope I'm not doing terrible things to your name, but Aniruddh, Molly,
Yes, yes.
okay, close, okay. And Liao is not here yet from China, so we will see what happens with them, and if they don't make it, then we'll have a little more time for discussion. And Antonio Goncalves from Portugal. So this is a really great representation. Rich and I are a little two-person curriculum development company. It works with Make, and we'll be talking later. But I'm just helping out here. So the idea is that each person takes about 10 minutes to kind of introduce their space, and we suggest a couple other things that would be particularly interesting for them to talk about. And then we'll have discussion. So let's sort of hold questions till after all three speakers. And if we don't have the third speaker, we'll have a bit more time afterwards for discussion. So I'll stop sharing my screen. And if it's okay with you, Aniruddha, you can go ahead and take on and introduce yourself,
Yeah,
that good stuff.
sure, sure. So, hi everyone. Right now it's a midnight in India, Gujarat state. So I'm from Gujarat state. It's the western coastal state in India. And I'm from IIT Gandhinagar. It's one of the premier government institution under the Ministry of Education, again Government of India. And we represent the Maker Bhavan. It's a kind of a academic maker space and which primarily focuses on the maker space in education. So teaching is there. Apart from it, we also encourage and support startups or the industry people regarding the experiential learning. So I'll take quick 5 minutes presentation and then 5 minutes for the short lab tour. So Divij is a student and project fellow in the Maker Bhavan lab, and he's doing his masters in robotics, as well as he's also working in makerspace and helping us to work with the student and mentor them and as a teaching associate. So I'll share my screen. I hope it's visible. It's visible. Okay. Yeah, so the programs we run, we call it experiential learning programs, where we indulge second, third, and fourth year of uh, graduate engineering graduate students to go through a project-based learning where we float a problem statement. You can see there are these three statement or projects we have work upon so far. It's a hands gesture, remote control, pick and place robotic arm, and then a conceptual mass rover mimicking model. And the third one is interesting. It's about a pneumatic glove for the rehabilitation for those who have paralyzed or partially paralyzed of their body parts and all. So starting with this pick and place robotic, so we have DIY pick and place robotic arm kits and all. The aim of floating such project course to aware the students how motors and actuators are integrated and they work together to deliver certain degree of actuation and movements. And there were six students for this project for mechanical engineering background, and they have designed this entire robotic arm from the scratch. And you can see the white and black color of parts. These all are 3D printed here in MakerBone lab. So we have our dedicated 3D printing facility. Sorry, and there is no post processing has been done with this piece of work. It's a raw 3D printed, and now it's been 2 years old. An additional part to make it more fun and interesting, the student come up with a idea of instead of having a remote control, why don't we have a glove itself? So you can see here, these are the flex sensors they have used for three finger movement, thumb and two other fingers. And there's a ESP32 board here and a battery and a couple of sensors. So you can actually remotely control this thing at a particular distance. These are the parts of the design process. This is again the testing and design stuff. This is a small video which is demonstrating how it actually works. So student is controlling using the glove, and by movement of the finger, the gripper goes down and it's picking up a certain amount of weight. In this case, we can able to pick 100 gram of any weight and place it from point A to point B. This is, yeah. So these are the modification of the gripper. So during this project, students face a very issue of the gripping part. So whenever they are trying to pick any certain object, so depend on the surface finish, if it's a slippery part, so the so the gripper actually lose the gripping stuff. So they have redesigned it using a TPU material which is mimicking the rubbery and flexible properties. This is like the future enhancement. I'm keeping it. The second interesting project recently last semester we have floated is a very basic structural Mars rover mimicking stuff. Now the a different thing what they have done is they did not use any microcontroller or Arduino boards to program it and in order to control these motors. They directly hardwire it using resistor. They made a circuit, analog circuit, and they made it in a working condition. So, and again they use so you can see they have used element extrusion and the MDF cut to they have used 3D printing, laser cutting and machining parts and all, and the electrical analog electrical circuit design part. So that this one is the interdisciplinary project and also challenge floated by a state government here itself. They want something without any coding and all stuff. They want to try with some defense projects. So this is we have come up with. This project is one of the interesting during the summer research. So we offer experiential learning programs for the regular IIT Gandhinagar students. Apart from it, we invite non-IIT students during the summer vacation. So this student is from NIT. Again, it's an engineering college, and you can see the blue or blue cyan color of fingers. So these are the silicon rubber material. It's not an epoxy. So they cast it using the conventional method, and they have used this pneumatic tube as pneumatic valves, which actually help them to fold the entire hand. Uh, so in general, what the solutions or pneumatic gloves available in the market, they only 2 degree of folding mechanism. What we have tried out here is to push like why don't we fold the entire palm, so it will helpful for the patient for the better improvement in a shorter time. Again, this is completely open source and we keep it low cost. We tried to make it so comparing, let's not go with the market scenario, but just to point out the available pneumatic glove in India, they range around 8,000 rupees to 50,000 around. Here we successfully achieved to make it within the budget of 5,000 rupees. So I think it's US dollar very very cheaper. I mean, but again it is giving us the better actuation and the self life is also good. So yeah, these are the glimpse of other activities. We also promotes like women and girls in the field of 3D printing, then conducting different programs. We call it curiosity for young kids. And yeah, one of our invention flagship program is invention factory. So this is migrated from New York, USA, from Cooper Union College. So two professors are actually visiting us during the summertime, and 20 students from different IITs they participated. So the USP of this program is to ideate, design, and make a prototype functional stuff, which can be patented in India and USA. So again, using making spirit and making ecosystem towards the direction of like product development. That's what we are trying. So we have started this in 2019, Invention Factory, and so far we have like filed provisional patents around 75, and out of 75 there are five projects are actually they converted them into a startup. So there's a conversion ratio also. And again, the glimpse of young makers. So class. So yeah, we done an experimental type of activity. So in rural areas, there are government school, and those kids they never see like machine 3D printing or laser cutting. So we received this request from via an NGO, and we conducted again a 3 4 day. I think it was a 4 days for program in 2024 last year, and we found very interesting that school kids of class 6 7 and 8, they don't understand English language as well in their vernacular language, their native language. They are able to develop a good projects. So this is something we tried out for the first time, and we were amazed with the results also. So we continued with that same program for each year for government schools only. This is the impact of like experiential learning program. So we started in 2019, and we trained 4,000 plus students, and there are regular curriculum courses. So steady slowly eventually we migrated regular curriculum courses to be run and teach through makerspace ecosystem. So now we are having the 40 courses, and we also float independent project courses, which I have shown three better courses. So far 66 students and 12 projects. And the key or the key takeaway is all these students when they join this project course or when they join makerspace and they start to work on any project in makerspace, after completion of any certain of project, they significantly improve their hands-on skills, which eventually help them to get a good job in Indian market. So that's considered as an employment impact as well. So this is what we are doing so far, and this is my work I have shared. I am actually taking care of this entire makerspace. There are professors are there who are the advisory panelist. And yeah, now Divij will just showcase you the how the lab is and what sort of machines are there. Divij, over to you.
All right. Well, thank you very much. So we'll have sort of a discussion slash questions after go ahead with Antonio, and I think we will just have the two speakers probably, but you never know. So why don't you go ahead, Antonio, and take it away, and then for 10 minutes or so, and then we'll talk and have questions and stuff.
Okay. So everyone is seeing the screen, okay? Okay. So I'm a teacher in Portugal for about 25 years, and since 2015, I started a Fab Lab. It's not a makerspace; it's a Fab Lab. And I started in 2015, and then with the idea of helping students to make their own projects, gain some autonomy. Since I think in the educational system in Portugal, we don't have it so much. So that's why I move along from a new project. And then in 1 year, we started an association, a private one, and we get some funds, try to work with people and with the community. And at this moment, we have two major projects. We work with the schools and so on, but we have two major projects. It's a conference, international conference, every 2 years. The last one was in July 2024. and the next one in 2026 about flexible learning spaces. So we are in Europe, near Spain, 45 kilometers north of Lisbon, and we live in an incubator. It's called Lab Center. It's a project from the municipality where they help startups to build their own business. And we have there also learning programs from a Polytechnic Institute of nearby, Leiria. And then there are other projects of robotics there also from the municipality. And we are there. We do a project for the community from several areas. We hear the first this picture here. It's a tree plant we did last November. Here down, it's we see you see my hand, the hand of sorry, the hand of the mouse. No,
Antonio,
no.
I don't think we see what you see on your
Oh,
presentation.
sorry.
It's still the title page.
Oh, sorry. Oh, what is happening? Sorry. Oops. Wrong turn.
Okay, now we see a picture with a slide with 4 pictures on it here.
Sorry.
Okay,
So
we're good now.
So I thought you saw this. So we live here in Portugal, 45 kilometers north of Lisbon, in a small town called Torres Vedras. Our space is in the lab center. The lab center is where the city hall make a project with startups. It was before it was a mall. It was abandoned, and then the city hall take over and rented it and put there some projects. We are there. And we do a project for the community. Here in the left side, we plant trees. Every year we plant trees. And then down, our students learn architecture, computer architecture. They maintain computers, and all the computers they can arrange, we send it to Guinea-Bissau, a country in Africa, where we have their project for about 4 years. We are helping them to use the computers, and at this moment they have and we have some a company Mauser that help us out too, and we send there some solar panels for them to have electricity and could use the computers. We have on the right side there is our city, our president of a mayor of the city hall, and she is presenting at the conference. I talk about, and then down there is a workshop with the community. This one was about rockets made of water and powder and so on. So one of the major projects we have, besides the conference, is the Fab Lab in a school, in a secondary school. That's our major goal, is to put Fab Labs in the schools, to implement, to propose the autonomy of students. So this is the team we have there. We have all of them, since the director in the sides, in the back, the director, and all the staff, several teachers from all of the areas, from math to design, to drawing, everything is there. So we help teachers and students and staff to build projects. And I am here to talk about a strategy that we use. It's an external assessment. So we invite people from the States and people from Denmark, Han from Denmark, Mikko from Finland, Christine is here attending, and Michael Stone the first time, and Liz. They were in 2022. They were there to see how it works in the year 0. It was the first year we implement the project on the school, and then the picture below, it's in 2024 in July, where they make the second report. The outcomes of this report are very important for this project. So the goal is to find weaknesses and potentials about what we are doing. So the methodology they use is we meet to set goals and to set also the domains that they are going to assess. Then they visit the Fab Lab. They interview the people that work there, from students to the city hall mayor. And then in the end, they make a short presentation at the boot camp. So what they assess is the leadership, the access. So if the Fab Lab is accessible to everyone, technical training, project development, curriculum design, the relation between the curriculum, the school curriculum, and the Fab Lab, and the environment, the environment specifically about the security. So what they give us is a detailed report of recommendation, observations, and concerns. So this is really, really important for us. And the impact is that in the second time they went there, they were really positive about our work. So for the team, it was a really important for the motivation. And it also promoted discussion about what strategy to choose in the future. Of course, when these guys came, they gave us a really big and detailed report, and we have to discuss and choose which recommendations, which concerns that we should put in a timeline. So it's really important because it keeps us focused on the job we have to do. So sorry. So in the end, another important thing is that we need a city to install a Fab Lab. It was Anne that said that in the last conference, and I really think this is a major strategy that we should have, because we need to have the politics inside, should have the staff inside, we should have the community as a whole, all the enterprises and so on, keep them in a place where we can build a better educational system for our students to be more autonomous and to be more to learn more for their own future. Thank you very much.
All right, if you want to perhaps stop sharing your screen. Okay, good.
Okay.
All right, well, thank you for that. Those were really two good presentations. And since we, don't have the third presentation, we have a little bit more time for discussion. So first, before I try to ask any questions, if any of you have any questions that you'd like to ask either of our speakers or compare your experiences or something. So if not, what do you think? What did either of you have a project that you wish you had done differently? It's we at Bakers we always say we learn from mistakes, right? Do you ever have anything that you wish you had done differently, or you wish you had done more of, maybe that maybe you did it too small and you wish you'd done bigger?
I don't know if I start.
Sure.
Well, in the beginning, this project Lab Aberto is a project that I have in the school, and then I bring it out of the school. And in the first moment, some students come with me to make projects, but the question is that at that moment I didn't have any support from the municipality. So that was a big mistake. And afterwards, 2 years afterwards, we plan to move that strategy in association that could have that support.
Okay, great. Mason had his hand up.
Hi, yeah, well, thank you all for presenting. My question is, how do you incorporate your local culture into your Fab Labs or STEAM labs? Something that I'm interested in doing is I have a multicultural school that I'm working at, with students coming in fairly regularly from international backgrounds. And something I'm interested in trying to do is think about, okay, how can we celebrate our cultural heritage in a STEAM mindset, or even partner with that to solve maybe errors or issues that are coming from, happening locally. And those are just things that I'm wanting to try to figure out. How do you connect that, your local culture to STEAM studies?
Aniruddh, do you have an answer for this?
Yeah,
I don't
yeah,
have,
yeah.
because in my project I don't have too many different cultures.
I would
So
like to,
that's not an issue for me, but
yeah, so I would like to answer this question because in institution like IITs, so students are coming from the different parts of India. So, all four directions, right? And they speak different languages, and we have to teach them the similar course or a similar activity. So, what we come up with a solution like, for example, where I do belong, it's Gujarat state. We all do, it's a dance, we call it's a Garba. Okay. So it's a 9 days of festival. So we indulge these festival activities into a robotics arm. So there are two wooden sticks, and you have to play with that wooden stick on a beat of a music. And folk songs are sung by, or recorded folk songs you can play. So there's a cultural creativity. There is a fun part, and I'm also engaging them with the robotics stuff. So we have a kit, pick and place robotic arm, and I asked the students. So by the way, Divij also has done some similar stuff. So you have to mimicking the steps what a human being is doing. That's a use case one. The second one is the we also introduce like organic or ecological materials. Okay, so for the vacuum forming and casting. So again, there is a 9 days or 12 days. So these are the cultural festivals. So there are idols made up of plaster of Paris or some other material which takes years and years, unlike plastics, to biodegrade. So we introduce clay, some organic stuff of ancient practices. But again, how can you mold it using a 3D printer? So can you make one clay 3D printer? It is there in market, but when you try to build one, you'll get to know about the motor drive, the pulley mechanism, the electronics, how the power, the current, the build volume. So the end goal is for them is to, I'm going to make an idol of my beloved god. But by doing that activity, they are learning so many technical stuff. So these type of like more interactive and likely or livelihood activities you can introduce. And yeah, it's not like if uh, students are from Gujarat, so they will only work with this type of projects. No, we force and encourage students to make a group of different states. So we keep minimum four group members, and we ask them, each one of you have to showcase what have you done so far, and we give them credits, marks or grades. And each semester we change this scenario. So another very good example, one mechatronic students, he's from Rajasthan. So you heard about Jaipur and Udaipur are very famous tourist spots in India, in Rajasthan. So there is a folk dance called puppet. So there are two small dolls, and there is a there is a folk person who can control these two dolls or puppets using the threads, using finger movements. So there's a finger movements, again motor actuation is there. You can introduce motor drives. So we asked him, and we give them a problem statement. So they have come up a automatic uh, puppet dance show using motor drives, SG90 motors, and Arduino board. So this is so they are also like they enjoyed a lot. they said we never thought like we can also make something like this. So those type of stuff you can float with them. And yeah, there are other more creative ideas, but you can start with this type of stuff as of now. Yeah.
Oh, that's really interesting. Let's see, Luke had his hand up for next.
Yeah, I was intrigued. Both your labs mentioned the need to solve problems or identifying problems to solve. I was curious how you both went about identifying what the problem that you had, how you prioritize the different problems you could solve for and how you chose what you chose.
That's a tough one. That's a really tough thing to do because in my case, I'm the one-man show, so I'm just the one that works there for 24 hours for all the time. So, and then I have people that come at Saturdays to people from the community that come. And so we need to have a lot of time for each project because we don't have enough staff to solve the problems. So most of the times, that's a strategy that we use a lot of time to do it in advance, and then a lot of meetings, and then choose particular project that we can make with the stuff that we have.
One of the things that we consult for a lot of schools, and one of the things that we do with teachers to get them to come up with an interesting project is to ask them what they've always wanted to teach, but they've never figured out a good way to demonstrate or show it. And I tell them not to think about whether it's possible or not, just to kind of talk to me about what's possible, what they'd like to do. And then if you're sort of driven by what people want to do, or some demo they'd really, really like to do. I've called it maker confession. They come and they don't know how to do any of this stuff. And you say, don't speculate that you want to do this with a 3D printer or something. Don't worry about that. Just, tell me what in ideal world you'd love to do in your classroom, you've never figured out how. And then, they'll just start talking, and then you can say, oh, well, you could use this and this and this. Then they're motivated to learn the tech as well, to do that. And so we've found that that's a good way to boot a makerspace from nothing, because it is hard to find problems, because you end up with a really trivial problem or a problem that's too hard, and like world peace or something, and what do you do with that, right? And so it's hard finding that middle. Let's see, we probably have time for another question or two. Liz has a space now. Yay. I know you're really interested in this area. Do you have a question or two to put you on the spot that we haven't
Oh,
covered?
thanks for that. So,
Hello, Liz.
hi, thank you for sharing. I'm at the Carnegie Science Center Fab Lab. So good thing I live near a couple labs that I could drive to when my electricity goes out. But thank you for sharing, both of you, about your places and spaces. I would like to ask actually from an improvement standpoint, talking about finding a problem and working on it in your lab. What How do you measure improvement? I know Antonio shared about the visiting global assessment committee, but for you, Arinda, how do you measure success, or how do you measure growth in these areas that you're kind of working on to improve?
So this is particularly for the students only, or you are asking for the makers?
Overall, for the makerspace, as your program is growing, how do you know that it's growing? What are your metrics?
So the measures are basically, there are three measures. One is we ask the students what the different experience or the different skill they have achieved. So before or they start with the program, let's say there's a first semester students, if I'm talking about, they don't have any idea about any machines, or they never seen any stuff like that. And after using or learning something like that, how they're planning to implement it in their upcoming 4 years of curriculum. So that makes a significant improvement in their, uh, of course, the grading system, but the way they look at any problem and they try to solve it. So that's point number one. The second one, we keep we also hire maker TAs. So there's a concept of, everybody knows it, train the trainers. Okay. So we ask these maker TAs to teach their juniors. So by doing so, they are also self-aware what missing information they don't know about any particular technology or any technique. For example, making a 3D model using a laser cutting machine using MDF or acrylic. So what are the material properties? They should have gone with that. That minor detailing stuff, technicalities. So that, and that's a really successful stuff also. The third one is the, of course, with the teachers and the faculties. So not only the students, but we also ask and encourage and push the teachers also. Why don't you learn it first? Okay, because a lot of teachers are visiting our maker spaces. They gone through 2 days, 3 days, 5 days of workshop, and the takeaway is like they are basically their primary aim to show a certificate as part of their administration. Okay, but we push them. You learn. Let's say there is a biology teacher, and the teacher is supposed to uh, teach them about anatomy of any uh, creature. Let's say human body anatomy or heart part. So or brain, right? So we encourage them, why don't you think about how can you develop such a model for small pieces of a human brain on a school level stuff, and then you showcase we using different colors. This is a um, small brain part, or the what are the brain different parts are there. So you also encourage teachers also, and these teachers are like, we segregate them with three different filters: basic, and then intermediate, and then advanced. So based on their interest, their availability, these are three types of measures. Overall, the major factor uh, can be divided into 2 points furthermore. One is by doing and learning, hands-on learning or making prototyping. They are encouraged towards more research area. Okay, in a very narrow, like narrow down their thought process. And the second one is the, if they are skilled, they gain the skill, there are high chances to get a decent employment opportunity in the market. That basically is, we are doing good with a surprise as well. So I'll give you an example. The pick and place robotic arm, it was designed by mechanical students. During their interview, final semester, they just talk about this project only, and they got the job. And this happened with a government organization. So there is a company who is into dairy business, and they have some factory, automated factory. They want to make it more smarter and automation. So they want people who understand automation. So this is how it creates impact. And of course, these are the measures.
And Kristen made the good point in the chat that she has business partners to take a real problem to get a real problem. Do you want to talk about that for a minute?
I can. So I teach in a high school, so it's 9th and 12th grade students. And especially in our junior and senior year, we have business partners who help us design our design challenges. We have design challenges per quarter. And by 11th and 12th grade, the students can choose what business partners and questions that they want to try to solve. Our 9th and 10th graders, we choose for them. And pretty much as freshmen, there may not be a business partner. By 10th grade, everyone's doing the same project. So we kind of release them gradually into being more autonomous in solving their problem, and having less scaffolds and supports from us as teachers, even though I explained it backwards. But it really seems to give the students that motivation to work really hard, because they have to present their solutions to those business partners who are very real with their feedback, which is awesome. And it's not doing things for teachers, it's doing things that are for the community, so it helps not just with motivation, but they're usually put more time into their projects that way too. It's not really about how I grade it. It's about them not embarrassing themselves, in front of a business partner. So it's a different kind of motivation, which is, I think, way better than me trying to motivate them myself.
Oh, no, no, that's great, and we're all kind of finding paths here, right? So it's really nice to hear that it's the same, that's roughly the same everywhere, right? That you have to find the good problems. And once you have a good problem, then that, can kind of lead to all kinds of good things. We have about 2 or 3 minutes left. Do either of the speakers want to add anything, or do you want to throw you both have taken down your final slide. So if you want to throw your email, your contact in the chat, you're welcome to do that. Or either of you have a final thought or two you'd like to make?
Yeah,
So,
just to add what you are talking, we're talking a minute ago about the how to motivate teachers to make the project, some project that they are keen to. But sometimes here we have only 12 hours or 24 hours to make a training. So what I usually do is to ask some colleagues to see what practical project could I develop during those 12 hours, because 12 hours is too little time to. So I managed to find one project that is really to have some kind of practical value, and then I develop it, and they change a little bit in the path. So that's a way to overcome the problem of having too little time to do a project.
okay. So, can we use this 2-3 minutes to give you a short tour of the lab, if possible?
Okay.
David, are you there?
Yes, sir.
Yeah, we can start with the 3D printers.
So should I give it or will you?
Yeah, you can just give a brief what machines are.
Okay, so these are the FDM Creality 3D printers, single nozzle printers. We have two of them in our lab. So you can see them over here. Moving on, this is our Bamboo Labs X1 carbon multicolor filament printer. You can use 4 different filaments at once. The printer automatically changes the filament as per the design. So you don't have to manually change the filament if you want a multicolored print. So I'll just show a sample if it's there. Wait, I cannot find it. Right. Uh, these are our Ultimaker printers. So these are double nozzle printers. So you can load 2 different types of material in them. So I'll just open the compartment over here. So you can see there are 2 different nozzles in these printers. So these allow us to load 2 different kinds of material for the same print. One is the printing material and one's for the support. And moving on to our resin 3D printers. So we have 3 resin printers from Frozen and 3 from Form Labs over here. So just to show you. So this is the platform of the Frozen resin printer. This is the tank and the cartridge is stored behind the printer. So this is where the cartridge is kept. And then for the resin 3D printing, we also have machines for the post processing. So these are the washing stations where we wash the print in IPA solution. And then we also have a UV curing. We have 2 of these UV curing station for the final processing. And moving on, we have a PCB milling machine where we can do a double layer PCB milling completely, including drilling operations. So we also have samples of the circuit boards made by first year students over here at IIT Gandhinagar, if you can see them. So these are working models made by PCB milling over here in our Maker Bhavan only. Moving on, this is our another bamboo multicolor printer. This is a smaller version. So you can see there are 4 different spools loaded in the printer, and the printer automatically selects the color as per the design. And this is a sample print, if you can see it, a multicolor sample print. And this is an older 3D printer from MakerPie. And I think that's all. Thank you.
All right. Well, thank you very much.